you know what it took to fire a cannon? What were the tools and implements used for the job? Come with me. Let me take you on a journey down history lane and find out. What exactly were the pioneering firearms that predated the cannons and early guns? Well, legend has it that around the 9th century, the Chinese used gunpowder for fireworks. But gunpowder soon found use as a military weapon in which it was filled into bamboo sticks and lit and fired at enemies at close range. A primitive gun, the fire lance, was created. Pebbles were packed in front of the gunpowder inside the bamboo stick, and the bamboo was tied to a hand weapon which then acted as a handle. To fire it, the gunpowder was lit through a hole at the back of the bamboo stick, and a forceful blast of firepower would emit at the other end. What we are seeing here is the unfortunate first man to experience the ugly side of the first technology in firearms. Now, let's go further and see how this simple firearm was developed to become a cannon in later years. As said before, it all started in China. By the 13th century, knowledge of gunpowder gradually spread from China to the Arab world. From there, it went across Europe, all the way to the United Kingdom. An English monk from Oxford, Roger Bacon, wrote what appeared to be the formula for gunpowder in Latin. It's interpreted as a mixture of 15% charcoal, 10% sulfur, and 75% saltpeter. These were ground up to a fine powder mixture which was also known as black powder. Saltpeter, or potassium nitrate, provided oxygen for combustion. Sulfur helped increase the rate of combustion. Charcoal was the combusting agent. Now, the devastating potential in gunpowder brought about more innovations. Early forms of bombs were created by filling up containers or kegs with gunpowder. A wick was lit from outside to ignite the powder inside. But more innovations followed. In the early 14th century, the hand cannon emerged as the first true firearm. It started off as a simple metal barrel with a touch hole that was ignited manually without the use of mechanical devices. These early firearms greatly changed the art of warfare and the rules of battle engagement. By the 15th century, as its use spread from Asia into Europe, the hand cannon was developed to become a matchlock firearm. Unlike the hand cannon, the matchlock had a mechanical trigger to ignite the gunpowder. It had a simple barrel attachment to a wooden handle. The base of the barrel had a little side hole with a small flash pan that held the gunpowder that ignited the main charge inside. To operate, a lever-like handle on the trigger was simply pulled upwards. This directly led to the invention of the modern gun. However, here we are looking at the cannon. It was also a direct descendant of the hand cannon. Firstly, let's take a look at the major components that make up a cannon. As a disclaimer, this is a depiction of a generic cannon with no particular make, model, or year of construction. Now, supporting everything, as well as holding the wheels in place, is the eggshell. But the major component on a cannon is the barrel. It's supported and pivoted on two parallel beam components known as chicks. The tail ends of the chicks are known as trails. In between the trails is the transom. On it is a hole with a metal ring around it called a lunette. This assembly was used to hook the cannon to a horse-drawn carriage for transportation. This is the middle transom. It supports the elevation screw, a mechanism used to adjust the angle at which the barrel is fired. We will look at it in detail later. Now, let's strip everything off and take a closer look at the barrel. The front narrow part is called the chase. Behind it is the reinforce. It has the first reinforce and the second reinforce. The rear end of the barrel is the cascable. The narrowest part of the chase is the neck. As we go towards the front end of the barrel, it bulges out into a conical shape to form the muzzle. We take a closer look at the muzzle, which is indeed the front opening to the bow. Now, we see the trunnions. These are two shafts which are perpendicular to the barrel. They hold or support the barrel onto its carriage. Their position forms a pivot on which the barrel swivels for aiming purposes. The vent hole is located at the back end of the barrel. It's a narrow hole that leads to the ignition chamber. The breech. This is the mass of solid metal behind the bore chamber. It helps to withstand the high explosive forces induced by the ignited charge. At the very end of the barrel, we see the knob. It was primarily used to tie ropes around it to secure the cannon as it recoils from the forces induced by the blast. As their name suggests, reinforced rings help reinforce and strengthen the barrel. It's time now to take a look at the inside of the barrel. We have the bore. This is the hollow part of the barrel cylinder which runs from the muzzle to the base on the other end. The diameter of the bore is known as the caliber. At the base of the bore is the ignition chamber. This is where the gunpowder is packed and ignited. Above the chamber is the vent hole or touch hole or fuse hole, which we have previously mentioned. As seen here, it connects the explosive charge inside with an ignition source from outside. A fuse is inserted or gunpowder is poured and fills it up. But to fire a cannon, certain procedures need to be followed and particular implements need to be used. Let's take a look at some of them. We start off with the ladle. This was a spoon-like tool that was usually made of copper and secured to a long staff. It was used as a measure for the gunpowder, as well as a tool to load the gunpowder into the barrel to the ignition chamber. Next tool is the rammer. It's a wooden cylinder attached to a long handle. As its name suggests, it was used as a ram to push or compact the gunpowder, the cannonball, as well as the wad into the back of the ignition chamber. We will get to explain the wad later. This is the gunner's peak or priming wire, a pointed piece of metal that was used to clear the vent hole and pierce the gunpowder bag. Up next is the linstock, an implement used to fire the cannon. As shown, it had attachments that allowed a slow burning lighter or flammable cord to be strung onto it. The spearhead could have been used as an emergency weapon to defend the cannon from enemies. The long staff or handle allowed the gunner to stand away from the cannon to avoid its recoil impact or possible ignition flashback. Now, let's see how these tools operated. We start off with the ladle. In comes the measured gunpowder pouch. In through the muzzle, the ladle carries the gunpowder along the bore all the way to the ignition chamber. Offloads and out it goes. This is the wad. It was usually made up of crumpled pieces of clothing material. It was used to close the windage gap to allow maximum force to hit the cannonball. What is windage? Well, this is the gap between the cannonball and the bore diameter. It allowed the cannonball to have relatively free movement within the bow. Now, it's time for the rammer to execute its ramming job. Once the wad is in place, The rammer compresses it against the gunpowder pouch. Next is the cannonball. Initially made from stone, cannonballs were basically made from cast iron. Back comes the rammer. Does another compression bit. Now, it's time to ignite the gunpowder. But first, we bring in the gunner's pick to pierce a hole on the gunpowder pouch. There we go. Done. Enter the linstock. As explained before, the vent is filled with gunpowder and the linstock is used as the lighter. Here we see a depiction of the gunner with the linstock and ready to fire. His position clearly shows he has taken precaution to be out of the way of a possible blast of gunpowder flashback or cannon recoil. Safety first indeed. Well, what do we have here? Looks like we've just destroyed this poor guy's little castle. Judging by the golden crown on his head, he must be a king. Well, sorry, Your Highness. Anyway, let's move on. So, after firing, the cannon needed to be prepared for the next shot. The first chore was to clean the ignition chamber and the bow. What were the implements used? This is the wormer. It was specifically used to clean the bow after firing. By twisting it around, the intertwined double screw with pointed ends would retrieve remains of wads and shredded gunpowder pouches. We have a little demonstration. The next cleaning implement is the sponger. It was usually a lambskin wrapped around a wooden cylinder. It would be dipped into a bucket of water, and the dampness, apart from cleaning, would also ensure that the hot debris or sparks from the gunpowder are put off. We take a look at the sponger in action. After everything was done and dusted, the muzzle had to be closed off. The tompion was used. It was a lid or cover usually made out of wood. It prevented unwanted debris or weather elements like rain from going into the barrel. We also need to take a look at other essential components of the cannon. This is the elevation screw. As its name suggests, it's a threaded piece used to raise or lower the barrel about the pivoted trunnions. The red line helps demonstrate the movement of the barrel. As the muzzle end goes up, the castable end goes down. Later models had more complex gear mechanisms for ease of operation. The quadrant. In conjunction with the elevation screw, the quadrant was used for adjusting and aiming the barrel. The plumb bob, tied to a rope, was used to read off degree markings on the quarter segment. As the barrel is raised, the plumb bob maintains the rope's vertical position as the quadrant changes its elevation and angular position. This allowed the gunner to adjust the barrel to the desired angle of discharge. Wasn't that neat? We continue. Here we see 3 shots being fired simultaneously with the same force but at different angles. The blue line indicates the path taken by a shot fired at 45 degrees. The green line indicates a shot fired at 30 degrees. The red line indicates a shot fired at 15 degrees. It's clear, a cannon's range is very much dependent on the angle at which the barrel is fired. Like the cannonball, any object that is propelled by an external force and moves freely under the influence of gravity and air resistance is called a projectile. The path taken by a projectile is called a parabola. Yes, parabola. Do we care to know more about the parabola? Okay, let's try a brief explanation and see how it goes. We start with a cone and a simple plane. The plane is placed parallel to the edge of the cone. Then it's moved inwards but remains parallel to the edge indicated by the red line. Now, the side of the cone whose edge is parallel to the plane is removed. Take away the plane. The edges of the dark blue area forms a parabola, as shown by the red line here. This particular parabola is equivalent to a projectile shot at an angle of 75 degrees. Now, let's take a look at what happens for a cannon to shoot off at high velocity towards its target. Firstly, we need to take into consideration two laws of physics. One, the law of conservation of momentum, which states that, barring friction and wind resistance, the linear momentum of a body or system of bodies in one direction remains constant unless acted upon by a resultant force in that direction. 2. The law of conservation of energy, which states that energy can neither be created nor can it be destroyed, but it can be converted from one form to another. Let's see where this takes us. Momentum. Momentum is a product of a body's mass and its velocity. Mass multiplied by velocity. Momentum is a vector. That means it has speed and direction. This also applies to our cannonball, speed and direction. So, here we have two principal bodies involved, the barrel and of course the cannonball. Both these bodies have initial momentum of 0. But hold on, before we go any further, we need to clarify that, for simplicity's sake, we will look at the mass of the barrel only and exclude the cannon carriage, right? We proceed. Now, for them to gain momentum, both the barrel and the cannonball need an external force to act upon them. This force, of course, comes from the gunpowder. Gunpowder has stored potential chemical energy which is released when ignited. The released energy exerts tremendous force on both the barrel and the cannonball. It pushes the two bodies in opposite directions as shown here. The black line is there just to show and maintain the center of our force as the two bodies are moved. But it really doesn't happen this way, eh? So, let's pull back our forces and try again. Now, this is where we bring in the momentum equation. The two bodies have mass and velocity whose products are equal but opposite in direction. Therefore, mass of cannonball multiplied by its velocity is equal to mass of barrel multiplied by its velocity. To get a bit real here, let's assume the mass of the barrel is 200 kilograms and it recoils at a velocity of 5 meters per second. Let's also assume the mass of the cannonball to be 10 kilograms. Now, we need to find the velocity of the cannonball as it exits the barrel. Bear in mind, these are assumed values. We solve our equation. 200 multiplied by 5 is 1000. So, 10 multiplied by the cannonball velocity is 1000 kilogram meters per second. To remain with velocity on one side, we divide both sides by 10 kilograms. The two 10 kilograms cancel each other out and we remain with the cannonball velocity on one side. The kilograms on the other side also cancel each other out, yes? And 10 into 1000 is 100. This leaves us with the cannonball velocity is equal to 100 meters per second. That is the velocity at which the cannonball exits the barrel, 100 meters per second. As we can see, the barrel also moves in the opposite direction at 5 meters per second. With both maintaining the same momentum, the lighter cannonball moves faster and much further than the heavier barrel. Now, a look at the conservation of energy law. We see that as the blast force exits the barrel, some of its energy is dissipated as sound and heat energy. The cannonball has gained kinetic energy, so the potential chemical energy in the gunpowder is conserved by turning it into heat, sound, and kinetic energy. Lastly, let's take a look at how the cannon was transported. Usually, a horse-drawn carriage called a limber was used. Moving on two wheels, it had a container box on top called an ammunition chest. Indeed, this is where the gunner's ammunition was kept. At the back is the pintle hook. Usually made out of brass, it was used to connect or hook the cannon carriage to the limber. One or two soldiers would ride on the limber and use the ammunition chest as a seat. Now, we bring in the cannon and hook it onto the limber. The lunette hooks onto the pintle. Here is an animated demonstration of horses pulling the limber and the cannon. Usually, 4 or 6 horses would be used. My name is Enoch Chihombori. I'm a mechanical design draftsman who enjoys working on 3D stuff. Every item in this video was modeled, textured, animated, rendered and edited in a free 3D software called Blender. Thank you for watching Enoch Graphics.